11.3, solving linear systems by adding or subtracting. So our essential question is, how can you solve a system of linear equations by adding or subtracting? Sounds pretty simple, and bear with me. This is a very long answer, but I assure you the process is really nice. All right, so if the coefficients of x and y terms, or right y terms, are the same uh, or are opposites, okay, you can add or subtract the equations to eliminate. Okay, and that's the key word: eliminate a variable. All right. Then you solve for the remaining variable and substitute that value into either the original equations to solve for the other variable. Okay, so let's take a look at what they're talking about here. So in example one, first things first, systems of equations can be solved by graphing. Okay, that's the first way we show you. That was in 11.1. Substitution, that was in 11.2. And then the third method is called elimination. That is 11.3, this video. Okay. So let's start eliminating. All right. So if you look at the system right here, all right, you would notice that we have a negative 4y with a positive 4y. Um, I'm going to go ahead and just add this system together. Okay. What is 2 plus 3x? Oh, that's 5x. What is negative 4 plus a positive 4y? Wait a minute, that's a 0. That's a 0y, right? These actually eliminate, right? They cancel out. That's why we call elimination, all right? They cancel out. And then negative 10 plus 5, you get negative 5. So in reality, all you're left with after elimination is 5x equals negative 5. Notice how there's like no more y anymore, right? All right, so division property. And lo and behold, we have x equaling negative 1. Okay, because negative 5 divided by positive 5. All right, so that's half of our answer. And now we go on to our next step. Plug it back in. All right, plug it back into which equation? I want to go ahead and plug it into the second equation. Okay, just because I feel like it. So my second equation was originally 3x plus 4y equaling 5, right? We already said that x equals negative 1, so we're going to substitute that back in. All right, this, ladies and gentlemen, is step 2, okay, of our process. Step 1 was here, okay? There we go. All right, so let's go ahead and substitute. 3 times 1, really, right? Eventually you'll get fast enough to where you don't even write it down. You'll just be like, oh, that's just 3 then. All right, so we got 3 plus 4y equals 5. Let's go ahead and use the subtraction property. And then we're left with 4y equaling 2. Division property. And that's reducible, okay? So that's y equals 1 over 2, right? Because 2 is half of 4. And there's our second variable. So our solution here, thank you, loud dog that's barking right now. My solution is, whoa, is at, note to self, I'm having issues with the at part. There we go, at, again, negative 1, because that's what we got for our x value. And then we got y, which is 1/2. So again, y, we got 1/2. There we go. All right, so there's our solution. All right, so you notice me doing like different methods, right? Or different steps. I was actually approaching it with the elimination method. That was the last example I did, okay? So step 1, okay, I added, and then I added the two equations, and I was able to eliminate my y, right? In that situation, example 1. Now, subtraction is an option as well. You can add, you could probably subtract, all right? It's optional. So it depends on the situation, and you're going to see an example in this video for that. Now, once you eliminate one of your variables, then all you have to do is solve for the other variable, okay? In my first example, I eliminated y, and I solved for x, all right? Next thing you know, substitute. Plug it in, all right? Once you plug it in, you should be able to get the second variable, or the value for that. And then basically you're able to write your solution in an ordered pair. Again, ordered pair, looks something like this. All right, x comma y, some value, comma, some value with the brackets, okay? All right, so example 2. I notice that if I was to add, that the y's would cancel out again, right? Because what's negative 2 plus 2? That's just 0. So I'm going to add these, okay? So 4x plus 1x is 5x. Very nice. And then again, the negative 2y plus the 2y, they cancel out. You get 0y, okay? Nice. And then 12 plus 8 is going to be 20. All right. So now I have 5x equaling 20. Notice how the y disappeared, okay? Because they eliminated, okay? All right, because 0 times y is just 0, so it doesn't even really need to exist, right? All right, let's get rid of the multiplying 5 by division. And then you're going to hit your first variable. X equals 20 divided by 5, which is really just 4. Okay, so that is the first half of your answer. All right, step 2. So again, this was step 1. We chose to add, okay, because the negative 2y and positive 2y would cancel out if we added. And then step 2, let's plug it back in, all right? We're going to substitute, and we're going to plug back in our x value. So I'm going to pick the cutest equation, which I think was the second one, because it was all positives and it's a little bit smaller numbers, so why not? Okay, so x plus 2y equals 8. And now we're going to plug in or substitute our value that we got in step 1 for our x variable. All right, so instead of 2, it's going to be 4. All right, I'm using the parentheses to make sure you understand I'm substituting. All right, 2y equals 8. So all we have is really just 4 plus 2y equaling 8. And let's isolate our variable y so we can solve for it. Okay, so let's get rid of the positive 4 with a minus 4. Okay, those will move them over. Okay, properties of equality. And then we have 2y equaling 8 minus 4, which is really just 4. Division property. Okay, and now we have y equals 2, which is our second half of our solution, which is at, okay, so our solution is at x, which we got 4, comma, our y, which was 2. So there is our solution. All right. All right, so example 3, as you notice, there's no opposites, okay? So if I was thinking to add this, it wouldn't work. It'd be 2x plus 2x, and that wouldn't cancel out the x's, and 6 plus a negative y is going to be a 5y, so you notice how they don't cancel out. So once you're getting in the situation, you realize addition is not going to work, okay? So we're going to solve by subtraction. Okay. Now, what's nice about this is I notice right away my x terms, my terms with x, are the same, 2x and 2x, right? So since these two are the same, I'm going to subtract instead of add, okay? Because 2x minus 2x, oops, sorry, my pen went a little nuts there. Again, 2x minus 2x, they eliminate, you get 0x, and then 6 minus a negative y is really, okay, so let me rewrite this. 6 y minus a negative y is really just 6y plus y, okay, because the double negative, okay, double negatives turn into a positive, okay? So 6y plus 1y is 7y. And then 6 minus the negative 6, 6 minus the negative 8, I'm sorry, that's an 8, negative 8. 6 minus a negative 8 is really just 6 plus 8, okay, because the double negative again. So 6 plus 8 is 14, all right? So all I'm left with is 7y equaling 14. How do you get rid of a multiplying 7? Divide. What you do one side, do the other, and you get y equals 2 because 14 divided by 7 is 2. And there you go. There's the first half of our solution. Now we found y, so now we just have to do step 2. So again, what I just did here was all step 1. All right. I just showed my work over here for you guys, just so you had an idea of what was happening with the math there. Okay, so step 2, substitute. I want to pick one of my equations. I want to pick, I'm going to pick the top guy. All right. I want to pick the top equation. 2x plus 6y equals 6. There we go. All right. Y was 2. Tell me why ain't nothing but a system. All right. Here we go. So we got 2x plus 6y. But wait a minute. Y we said was 2. So I'm going to substitute it in. So we got 2x. 6 times 2 is 12. And that's still all equaling 6. Thank you, Pen, for all your glory right there. There we go. All right. Subtraction property. What you do to one side, do the other. And now you have 2x equaling negative 6, okay, because positive 6 minus 12, negative 6. Division property. Sorry, I'm going a little bit lower there than normal. And eventually you get x equaling negative 3 because positive, or negative 6 divided by a positive, it's going to be a negative 3. Okay, so negative 6 divided by positive 2, negative 3. All right, so our solution is at what we got for our x, okay, which was negative 3, comma, our y, which was at positive 2. And there's our solution. All right, so your turn number 1. Go ahead and solve. Notice how it says adding or subtracting. So be aware of the situation. Is this a situation where you can just add and you immediately see a certain term cancel out with one another? Or do you need to subtract because you see two that are exactly the same, two terms, with a variable that are the same? So try to figure that out, okay? And let me know which ones that you chose, okay? All right, your turn number 2. Same deal, adding or subtracting. Okay, so just be aware of that. And again, do you have two opposite terms, with an x or a y, or that can cancel out if you just add? Or do you have two terms that are the same, and if you were to use subtraction, they would cancel out just fine with elimination? Okay, so you tell me, and then show me right away. Okay, thank you guys. And if you have any questions, let me know.